In this video series, I work through a math problem or problems each video. Since the variables in rational expressions take place of real numbers, properties of real numbers carry over to rational expressions. When we multiply two rational expressions together, we can rewrite the expression as a single fraction with the numerator equal to the multiple of the two original numerators and the denominator equal to the multiple of the two original denominators. Once we have a single fraction, we can carry on as we did in the previous video and cancel out common factors to simplify these expressions. Note that if we want, we don't have to write the expression as a single fraction first. If an expression we can treat as a single unit in any numerator matches an expression we can treat as a single unit in any denominator, we can cancel out the matching expressions. Let's take a look at the example. We need to simplify the following expression. The expression is 3x cubed y minus 21x squared y plus 20xy divided by 12x to the fourth power z minus 36x cubed z minus 120x squared z multiplied by 8x squared plus 40x plus 48 divided by 5x plus 25. Let's go ahead and start by factoring out what we can in both of these rational expressions. First, we're going to start out with the numerator of the left fraction. If we look at 3x cubed y minus 21x squared y and 30xy, the coefficients have a factor of 3 in common, so we can factor that out. And if we look at the x and the y's, this x here has the smallest exponent, so we can factor x out and y out as well. When we do, we're left with x squared minus 7x plus 10. Let's go ahead and do something similar to the polynomial in the denominator. If we look at the numbers 12 minus 36 and minus 120, they have a factor of 12 in common. If we look at the x's, x squared is the x with the smallest exponent, and they all have z in common, so we can factor that as well. And once we factor 12x squared z out from the polynomial in the denominator, we're left with x squared minus 3x minus 10. And we're going to multiply this fraction by, let's go ahead and factor what we can for both of these polynomials in the second fraction as well. 8, 40, and 48, these numbers have 8 as a common factor. And when we factor this number out from the polynomial here, we get x squared plus 5x plus 6. 5x plus 25, these terms have 5 in common, so we can factor that out, which leaves us with x plus 5. Next, let's go ahead and take two steps at once. We can rewrite this multiplication of two rational expressions as a single fraction, and we're also going to factor these three polynomials, these three quadratics, since they can be factored into linear factors. And let me do one more thing. If we look at these numbers and letters in front of the two quadratic expressions, we can divide out or cancel out common terms. So let's go ahead and do that. 3 and 12 have a factor of 3 in common. So we'll be left with 4 if we divide both 3 and 12 by 3. If we compare x and x squared, we can divide out a factor of x from both of these variables, and we'll be left with x. And let's go ahead and factor this polynomial first, x squared minus 7x plus 10. Since the leading coefficient is 1, we know we get x and x. 10 is equal to either 1 times 10 or 2 times 5. And since this is positive, we know that we either get 2 positive numbers or 2 negative numbers. Since this number is negative, we're going to want to write 2 negative numbers here. 1 plus 10 is 11, which doesn't match 7, but 2 plus 5 is equal to 7. So that matches. So if we factor x squared minus 7x plus 10, we end up with x minus 2 multiplied by x minus 5. Next, let's factor this polynomial, x squared minus 3x minus 10. Once again, the leading coefficient of 1 tells us that we can start by factoring this polynomial into x and x here. Once again, we have 10, so we know we either have 1, 10 or 2, 5. This minus sign tells me that we either have plus and minus or minus and plus. Either way, the signs of the numbers we write here are opposite from each other. So we subtract the numbers. So if we take 1 and 10, 10 minus 1 is 9, which doesn't match. But if we take 5 and 2, 5 minus 2 is equal to 3. So we know that we need to write 5 and 2 here. But the minus sign in front of 3 here tells me that we need to make the number that's larger in absolute value, which is 5, the negative number. So we're going to make 2 plus, and that way, when we use FOIL to multiply this out, the middle term will be minus 5x plus 2x is minus 3x, and it does match up. And we have 8 and 5. I can copy the x plus 5. And now we need to factor x squared plus 5x plus 6. So once again, we start with x and x. And 6 is equal to 1 times 6 or 2 times 3. The plus sign here tells me that both of these numbers are either positive or both negative. But since we have a plus sign here, we know that the two numbers must be positive. So let's make these signs plus. 1 plus 6 is 7, which doesn't match, but 2 plus 3 is equal to 5, so we can go ahead and write 2 and 3 here. Now we can go ahead and just cancel any common factors. So if I look at what we have in the numerator and the denominator, I first see that we have 4 and 8 here. 4 divided by 4 is 1, 8 divided by 4 is 2, and let's see, we got x plus 2 and x plus 2, so we can cancel them out. And let's see, we got x minus 5, and that should be it. So we'll just go ahead and write what's left. We usually write the number first, so I'll go ahead and write 2, then the y, and we have x plus 3 left. And in the denominator, we have the number 5, xc, and x plus 5 left. So after carrying out the multiplication, factoring, and simplifying what we had, we're left with the fraction or the rational expression 2y multiplied by x plus 3 divided by 5xc multiplied by x plus 5.